Hello student, hi, good evening. So today we are going to discuss about waveguide. So this is a circular waveguide, okay. So because it is whatever we are doing, we are just discussing according to question, okay. So whatever the question is there, because we are solving the series of question paper of ISRO 2018. So here the question number 69 is about circular waveguide. Okay, circular waveguide. First of all, we will see about what waveguide. We will see about what waveguide. 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 Okay. So what is actually the waveguide? Okay. So I think it is not visible. Okay. So here waveguide. See waveguide. Waveguide. Okay. So what is waveguide? First of all, before solving the question, we are discussing about this topic waveguide because the question is based on waveguide. That is from circular waveguide. Okay, circular waveguide. So, what is waveguide? What is waveguide? So, do you know what is waveguide? Waveguide. What is this waveguide? See, waveguide is nothing but it is a structure. Yes, waveguide is a structure, so which will support and which will direct or which will guide what, which will guide the wave. Yes, which will guide the wave through it. Okay, so which will guide the wave. Okay, so with minimum loss of what, energy, with minimum loss of energy. Why we are using waveguide? Why we are using waveguide? Waveguide are used to support the wave or direct the wave or guide the wave through it with minimum loss of what, energy, minimum loss of energy. Why actually we use? Because let's say there is what, there is one x person and there is one y person. So they want to what, they want to communicate. Yes, they want to communicate with each other, x and y. Okay, so this is my x person. Yes, and this is my y person. Yes, this is my y person. They both want to communicate. Yes, they both want to communicate with each other, and both of them are, like, let's say 2 kilometers far away. Yes, 2 kilometers far away, and they want to what, they want to just communicate through what, through small, through a device like mobile. Yes, mobile phone. So they want to communicate with each other. They want to communicate with each other. Okay, so now as because as you know very well, this small device like cell phone, it has what, it has an antenna. So this is what, antenna, small antenna. Now this, through this antenna, what the signal will get what, radiated from this antenna. Okay, so this is what, electromagnetic wave. So this signal will transmit in the form of electromagnetic wave. Okay, as he will speak in acoustic wave. First this acoustic wave, whatever he is speaking, that will convert it through a transducer into a electrical energy form. Then after that, this electrical energy form will get transmitted through this what, through this antenna, through this what, antenna. So the antenna, there is what, this cell phone has an antenna. Okay, so it will transmit this electrical energy in the form of electromagnetic wave throughout the space. Now through space, when this em wave will get what, em wave will get radiated throughout the space. And so this will radiate like what, so spherical waveform. Yes, like this spherical. Yes, so this is what spherical. So in this manner this electromagnetic wave will get radiated throughout the space. Okay, so in the manner of what, in the manner of 1 by r square. Yes, in the manner of 1 by r square. So whatever he is speaking in this cell phone, so here it is, oh, it will get whatever the information. Let us say there is 100% information, whatever he is talking in this cell phone. But here it will what, it will get only, it will get some around 60% of information. Okay, so other information will get lost whereas this electromagnetic wave is transmitted throughout the space, throughout the space. Okay, in the manner of what, in the manner of 1 by r square, 1 by r square. Because as the distance increases, this electromagnetic wave will get attenuated. Why? Because, and hence if we see here, the energy is get attenuated as distance is very large between these two person, x and y person. Okay, so now what is the Then is there anything, so is there any any device that can support this electromagnetic attenuation, which will what, which will reduce this attenuation? So is there anything, so that is what, is there any medium, okay, so through which we can transmit this what, this electromagnetic wave, okay, so some type of medium we require, okay, so that loss should be, so that the electromagnetic energy loss should be as minimum as possible. So there is what, there come the what waveguide, there come waveguide, okay, so waveguide, these waveguide are used, okay, so this waveguide is used, it is a structure, it is a metallic hollow metallic structure, okay, this waveguide is a hollow metallic structure. Now these two person will talk through this what, through this waveguide, okay, so there is a waveguide. Now this waveguide, this electromagnetic wave will get transmitted through this what, waveguide, through this waveguide. Let's say this is a rectangular waveguide, what, rectangular waveguide. Let's say this is what, rectangular waveguide. Yes, we are using rectangular waveguide. Through this electromagnetic wave will get transmitted. Yes, transmitted. Now here with low loss. Yes, with less attenuation. So there is a very low loss of signal, very low loss of this electromagnetic wave. Okay, so with low loss of energy. Okay, so very less energy which getting lost when we transmit this electromagnetic wave through this waveguide, instead of transmitting the electromagnetic wave throughout the space. This is the main reason that we are using the waveguide, because the wave, when this guide will support this wave or guide this wave in guide this wave through this what, along this tube, in along this metallic tube, then they with low loss, okay, with minimum loss. Yes, with minimum loss, by what, by restricting, okay, so by restricting the transmission of energy to a particular direction, okay. So this is what reason why we are using the waveguide we are using, because if we transmit the signal, if we transmit the electromagnetic wave without using any without, so if we transmit this electromagnetic wave throughout the space, because it will radiate in the manner of what, 1 by r square, okay, 1 by r square. As the distance increases, this electromagnetic wave will get attenuated, and whatever the information is what is sending here, this y person is getting only 60% of this, okay. So in order to reduce this attenuation, we are using the waveguide, okay, waveguide. These waveguide, okay, so these waves are what, these waves are microwaves, okay. So microwave means high frequency of waves, okay, high frequency of signal. So whose frequency range is from 300 megahertz to 300 gigahertz, okay, 300 gigahertz. So that's why, as we go for high frequency signal transmission, there always we use the waveguide, okay. So we are using waveguide for generally for high frequency signal transmission, because if we will not use this waveguide, then there is a lot of attenuation of this electromagnetic wave, and very less information will that this person will get from this x person, okay. So this is the main reason why we use the waveguide. So waveguide. So now how we can, in other way how we can define this waveguide. So now you can also write the waveguide. So what is a waveguide? Waveguide is a what, waveguide you can write also waveguide. What waveguide? Waveguide is a waveguide is a metallic waveguide is a metallic okay. So waveguide is a metallic structure, okay, metallic tube structure, you can see tube structure, okay. So which support or you can say which support or which guide or you can say which direct what which direct or which you can say which direct the wave. Yes, wave, okay, wave through metallic tube, through metallic through metallic tube. Yes, metallic tube. So this is what waveguide. Waveguide is a metallic tube structure, so which will support or guide the wave through it with you can say with minimum loss, with minimum with minimum with minimum loss of energy, with minimum loss of energy. Yes, with minimum loss of energy by what? By restricting the transmission energy, or you can say what? By by restricting by restricting the by restricting the transmission of energy, transmission transmission of energy transmission of energy to a particular direction, to a particular direction, to a particular direction. Okay, so this is what waveguide. So waveguide is a metallic structure, okay, metallic tube structure which support or guide or direct the wave through it with minimum loss of energy by restricting the transmission of energy. Whatever the energy this guide is transmitting, it will restrict to a particular direction. Okay, so other way you can say the waveguide is a type of transmission line. Yes, it is a type of transmission line to transfer or to transmit the power. So this is all about waveguide. Okay, and also we know very well waveguide that we use for the microwave frequency. What? That we use for microwave frequency, microwave microwave frequency microwave frequency signal. Okay, microwave frequency signal whose range is from 300 megahertz to 300 gigahertz. All this type of high frequency microwave signal transmission, we need waveguide. For low frequency signal transmission, we use generally coaxial cable and parallel transmission line for low frequency signal transmission. For high frequency signal transmission, we are using waveguide. For low frequency signal transmission, we are using coaxial cable and parallel transmission line. Okay, so this is about waveguide. So now we will see what about how many type of waveguide is there. So generally we are what using, okay, in day to day life, that we use the waveguide like circular waveguide, rectangular waveguide and circular waveguide. Okay, so we generally use the rectangular waveguide and circular waveguide. There is also other type of waveguide like elliptical waveguide, single wrist waveguide, double wrist waveguide. Okay, so these are the type of some waveguide, and generally we are using two type of waveguide, rectangular waveguide and circular waveguide. But here we want to what discuss about circular waveguide. What? Circular waveguide. Actually this is what about question. Okay, so because of what the question is given about circular waveguide, so that's why we just introduce some type of waveguide. What is actually the waveguide, why we are using the waveguide, what is the purpose of the waveguide. Okay, so here we will see the circular waveguide directly. Okay, so what is this circular waveguide? As you know very well, this is what single conductor. Okay, so the whose cross section is like circular, so it's like a cylindrical shape. Okay, so this is what circular waveguide. Okay, so through this waveguide, we are transmitting the signal. Okay, electromagnetic signal. So we are transmitting the electromagnetic signal through this circular waveguide. Okay, so here is the radius of this circular waveguide. Okay, so now see here, just we want to see some advantages of this circular waveguide compared to rectangular waveguide? See, first is what this circular waveguide here. Installation of this circular waveguide is easy. Okay, so installation. If we see installation of circular waveguide, installation of circular waveguide is easy. Okay, then what? Then the rectangular waveguide. Then the rectangular waveguide. Okay, so installation of circular waveguide is easier than rectangular waveguide. So this is what first type of advantages, and second type of advantages that you can get the join, which is joining of circular waveguide is again easier than rectangular waveguide. Yes, joining. So you can say the joining of circular joining of circular waveguide is easier. Joining of circular waveguide is than easier than rectangular waveguide. Rectangular waveguide. Yes. So joining of what? Joining of circular waveguide is easier than rectangular waveguide. And third, what you will get here. So third disadvantages here is that TE. What? TE01 mod. So if we see the TE01 mod have what? Less attenuation, very low attenuation. TE10 mod. Yes, TE10 mod have very less attenuation. Yes, attenuation. So if you see TE01 mod, that TE01 mod of circular waveguide have very less attenuation, and hence it is suitable, and hence you can say hence it is suitable, hence it is suitable for long distance waveguide transmission. Waveguide transmission. Yes, so that is what these are some advantages. So first, installation of this circular waveguide, that is very easy. Joining of circular waveguide is also easier than rectangular waveguide. And third is that particular mod TE01 mod in case of circular waveguide. So this mod have very less attenuation, so therefore we can say that it is suitable for long distance transmission, long distance waveguide transmission. Okay, so up to very long distance transmission, if we want to transmit the signal up to very long distance, then it is much suitable. This mod is much suitable. Then in that case we will go for circular waveguide instead of rectangular waveguide. Yes, so this is all about its advantages. And if you see disadvantages that I will tell you about, like disadvantages is about its dominant mode. So dominant mode in case of circular waveguide, that we see here. What is the dominant mode for circular waveguide? Dominant mode. So this is what? Dominant. Dominant mode of circular waveguide. Dominant mode for circular waveguide is TE11 mod. TE11 mod. Yes, TE11 mod. So, but actually in this dominant mod, there is a very large attenuation. Okay, so it's very high attenuation, is very high different. What we can say interference. So okay, so in this particular mod, that is dominant mod, here the interference is very large. Why? Because if we see this waveguide here we can see the tapering of the signal is very high. Tapering means nothing but the diffraction of the electromagnetic wave. diffraction of the electromagnetic wave. When the electromagnetic wave will strike the boundary of this circular waveguide, then it will get scattered. It will get scattered because of maybe some roughness, maybe some rough surface of this circular waveguide. So in order to what? In order to reduce that diffractions or tapering of this signal, this electromagnetic wave, so this circular waveguide, this that must be what? That must be smooth, okay, instead of what? Instead of roughness. If roughness is there, it's a boundary, like if the surface is rough, if the surface of this circular waveguide is rough, then definitely there is a tapering of the signal, means there is a diffraction of the electromagnetic wave, okay. So when the wave will strike the boundary of this circular waveguide, then in that case that signal will get scattered, okay. So that will get scattered, and therefore there is a lot of interference in this particular mode TE11 mode, so which is a dominant mode. Okay, so this is one of the biggest disadvantages that we found in case of what? In case of circular waveguide. Yes, in case of circular waveguide. So here, so that is about this dominant mode. Yes, we have seen what? We have seen advantages, and we have seen one of the biggest disadvantages. That is what? That is lot of it. That is a very large different means interference that will occur in this particular mode, that is dominant mode. Why? Because dominant mode. Why? Because there is a tapering of the signal, means there is a diffraction of the electromagnetic wave. When the electromagnetic wave that will strike the boundary of this circular waveguide, because of its roughness, then that signal will get what? Scattered. Okay. So once it will get scattered, then definitely there is a loss of energy. Okay. So loss of energy of this electromagnetic wave, which is transmitting through this circular waveguide. Okay. So this is all about what? This is some. Okay, it's not a complete explanation. This is because of the question that we found in this question paper. So that is question number 69, that is about the circular waveguide. For that purpose, I thought first of all I should introduce about waveguide, what actually the waveguide that we have seen, why we are using the waveguide. Okay, so that also we know very well. If you want to communicate very long distance, okay, your friend is very far away from you, so like about 4 kilometer or maybe 10,000 kilometer very far away, then how you can transmit your signal from your acoustic wave signal to that person, to that X person, Y person, that is he is your friend. Okay, so how he can get your information. Okay, so if you will transmit that information without using this waveguide, okay, so then there is a lot of attenuation, and definitely because the electromagnetic wave that will transmit, that will radiate throughout the space in the form of what? In the manner of 1 by r square. As the distance increases, signal attenuation will get decreases. Okay, so for that purpose we are using this this waveguide. Yes, waveguide. So waveguide is used for high frequency signal transmission whose frequency ranges is from 300 to 300 megahertz to 300 gigahertz. Yes, so now let us come to this question. Okay, so this is all about circular waveguide. So this is small explanation, it's not a big. Okay, so it's just a glimpse for this circular waveguide. Okay, so now let us see the cutoff frequency, because now we are going to solve this question that we are getting here in this question paper, that is question number 69. Question number 69. Yes, so this is about the cutoff frequency of what? So a cylindrical waveguide with radius. Okay, cylindrical waveguide with radius is given as 3.5 centimeter, 3.5 centimeter, has wave traveling. Okay, so has the wave traveling in tm1 to mod. So 1 to mod of transmission, that is given as tm1 to mod, tm1 to mod, tm1 to mod. So this is what? tm1 to mod of transmission. Yes, through this mod we are transmitting the signal. So in circular waveguide, the value of the first zero and second order Bessel function is this is x n p. Okay, so x and p, n will tell us n will tell us zeros. So this n is what 1 and p is what 2. P is indicating what order and n is indicating what root. Okay, so root. So this is x and p and it is given as what 7. This is given as 7. So now asking what about find the cutoff wavelength of this mod. Find the cutoff wavelength of this mod. As we know very well, cutoff wavelength is nothing but lambda c is equal to what 1 by fc. 1 by fc. So cutoff frequency that we know very well. Cutoff frequency fc is equal to what? fc is equal to c by 2 pi 2 pi a square root of epsilon r into x and p. Yes, this factor, this we can calculate from what? Basal function coefficient. Here it is given. Okay, so this factor is given here. X and p is equal to 7. So this is for particular mod tm12 mod. Yes, so now you can calculate cutoff frequency. So just put this cutoff frequency here. Lambda is equal to c by f. So this is actually c by f. Lambda c is equal to c by f. So lambda c is equal to c by fc. What is fc? C by 2 pi a. So 2 pi a square root of epsilon r, because it is a air filled rectangular waveguide. Yes, circular waveguide. Circular waveguide is filled with air. Okay, so air. So as we know very well, for air permittivity is what 1. Permittivity is 1. So this is c. So this will come down. So this is x, c into x into x and p, x and p. Okay, so this is lambda c is equal to c by fc. So c will get cancelled and we are left with what? We are left with 2 pi a. 2 pi a divided by x and p is what? 7. So now see here, lambda c is equal to what? Lambda c is equal to 2 pi a. A is how much? A, if you see here, a is given as 3.5 centimeter. Yes, so and this x and p is given as 7. So this is nothing but 7 pi by 7 centimeter. Yes, so this cutoff wavelength is nothing but pi centimeter. What? Pi centimeter. So this is my pi centimeter wavelength. Yes, cutoff wavelength. So for that we can say the option A is correct. Yes, option A is correct. So this is question number 69. So this is about what? Cutoff wavelength in case of circular waveguide. Okay, so this is about circular waveguide. So main formula, if you see for cutoff wavelength, is this. Okay, c by 2 pi a square root of epsilon r. So this is relative permittivity of what? Medium. Okay, so means how the medium is filled of, means what is filled in within the circular waveguide. Is there air or any other medium? So for that their permittivity should be different. Okay, but here it is air. For air the permittivity is 1. So this is x and p that we can calculate from what? From Basel function coefficient, and here it is already given. So just we have to put here. So this is what? Cutoff frequency for circular waveguide. So that's all about